Hey guys, happy Tuesday. Hope you had a wonderful long weekend and are ready to start another week. Only 4 more, including this one, to go. So let's finish the year strong. I know we're all getting antsy because it's so warm outside, but 4 more weeks of focus and then you are free. We're finishing up chapter 9 today, tomorrow, Wednesday, and then we are moving on. That would be Wednesday when you're listening to this, so we're jumping into chapter 10, which is our last chapter. All right, so 9.4 is all about different types of data displays. So take some time to pause the video and get down all of these data display examples, and then more importantly, the what does it do right here. You can also draw a picture of it if that will help you if you're not sure what it is. But just to go through them quickly, a pictograph is kind of elementary, not one that we're going to use too often, but worth knowing. So this is for specific pieces of data that you want to represent using a picture. Obviously it's going to be something with a low number, or you're using each of these little pictures to represent a larger amount. So maybe you're saying 1 bird equals 100, something like that. Okay, next up we have the bar graph, which we're going to use quite often, so I'm going to put a star next to that one. The bar graph is really good for showing data in specific categories. So for example, if you're surveying people on what is their favorite type of ice cream, you could easily put type of ice cream on this axis and then the number right here on the y-axis. Circle graph is also another one we're going to use a lot. This is showing data as parts of a whole. That's really important for you to note about a circle graph, is you're going to use this one most often when you're talking about a part of a whole population or whole amount of something. So typically we'll use percentages for that. Line graph we're going to use a lot. It shows, this is really important again, the wording, how data changes over time. So basically the shape of that line, and this is a pretty infamous image for when we're talking about growth of companies. Obviously companies want to see this type of a pattern where they are constantly increasing, but if a company is seeing this, they're obviously a little bit unstable. So they need to figure out why that's happening. Histograms are kind of unique. The wording on this says it shows frequencies of data, and so basically what that means is whatever's on your x-axis is going to be related to time. So for example, if I'm talking about people's ages, really there's nothing in between time, right? Like time keeps going on. Whereas if I had something like, again, looking at this bar graph compared to the histogram, there are no spaces in between the histogram. And again, that's because this is on this axis talking about some sort of a time. Whereas this, I was just talking about ice cream. I can put spaces in between ice cream because they're totally unrelated categories. But in a histogram, again, your x-axis is typically going to be a unit of time. Sorry, that says time. Alright, a stem and leaf plot is really the only reason you're going to use this is to order numbers. So if you have a large set of data and you have to put them in numerical order because maybe you need to do the next one, a box and whisker plot, or you need to find the mean, median, mode, range, minimum, maximum, those types of things. Stem and leaf plots' only purpose is to, well, I guess not only purpose, but main purpose is to organize them. And then I guess what they're saying here is how they are distributed. So basically, how many in the 20s do you have? How many in the 30s do you have? How many in the 40s? And so on. Box and whisker plot goes right along with stem and leaf. This one is a little bit more useful though, where you're going to show the variability. So meaning you have a set of data. This is going to show your minimum and maximum. I think you guys learned box and whisker plots last year, but if not, it's definitely worth checking out on Khan or IXL. I'm not going to take the time to go over specifics on that right now. But basically, this is the box, these are the whiskers. The box represents the main portion of the data. And so this one's not used super often, but still sometimes. A dot plot is kind of along the lines of a pictograph, so kind of elementary. We won't use this one too often. And then finally, we obviously know we're going to use a scatter plot a lot. And this one, the key thing here is that it's going to be 2 data sets. So I know all of these are 2 data sets because we're talking about number or frequency of things like how many people chose chocolate. That's not really comparing 2 different data sets. If you're comparing somebody's arm span to their height, that would be comparing 2 different data sets. So that's going to be used for a scatter plot. So again, I would say, I forgot to put a star by this one, but the most ones we are going to use are the bar graph, circle graph, line graph, and scatter plot. Okay, so that being said, let's jump into example 1. We are to choose an appropriate display for this situation and explain. So I just want to start by saying that there is not only one right answer here. You can defend your answer, but there are good answers. So, I mean, yes, you could technically be wrong because there are certain things that don't work, but you could make things work. It's just what works the best. So for this one, the number of students in a marching band each year, because we're talking about, because of the words each year, the best option here of our options would be a line graph because of that reason. It's changing over time. So obviously the reason that we're doing this is we want to see how it's increasing or decreasing each year, or if it's staying stable. So we want to say line graph for this one to show the change over time. Okay, for the second one, a comparison of people's shoe sizes and their heights. So that's almost exactly what I was just mentioning with the scatter plot. As soon as I read that I'm talking about 2 different variables, shoe size and height, I know I'm comparing 2 data sets. So scatter plot would show the relationship best on this one. Okay, on your own, try these 2, and again, I know there could be multiple answers, but try to choose the best one and explain why you think it's the best. Pause the video and then come back here and check. Alright, so here we are. Number 1, you may have said circle graph. You may have also said bar graph, but the best option would have been histogram because this is one of those unique situations where we're talking about frequency. So like people in between 0 and 20, and then 21 and 30, really like there's no break in the middle. You're either 20 or you're 21, so you're 20 until you're 21. And so the best option there to show that there's no break in between would be the histogram. Would it be wrong if you said circle graph? No, but I just think that histogram would be a better option here. For number 2, the percents of students in your school who play basketball, football, lacrosse, or soccer, a bar graph or circle graph would be good here. Again, you could use some of those other things like pictographs and dot plots and that kind of stuff, but I would say one of these 2 would be the best because it's showing data in the specific categories. Okay, here we go on example 2. You record the number of hits for your school's new website for 5 months. Tell whether the data display is appropriate for representing how the number of hits has changed over the 5 months. So that's the most important thing here is what's appropriate for representing how it is changing. So change over time. So letter A, the bar graph, looks good. We can see that clearly not very many people visited in August, September, but it was increasing over time. So yes, this is appropriate because it shows the change. I don't even know if I want to word it like that, actually. I'm going to say it shows the number of hits each month. For letter B, the histogram does not show that, and this, if you've been wondering about histograms, here's exactly what it looks like. So the number between 0 and 399, the frequency would be 2. So how many how many hits were between 0 and 399? This doesn't even make sense. So no, this is not appropriate because it really doesn't show the time factor, how it's changing over time. And finally, letter C is another good example. This line graph is showing how it's increasing from August to December. So once again, this is showing change over time. I keep wording it the same way, but honestly, that's kind of the best way to describe this. You could also say it's showing how it's increasing from August to December. Okay, so on your own, again, pause the video and see if you can decide if any of these would be appropriate for example 2. So you're going to have to go back to example 2 and see what you think about these ones. Pause the video and then come back. Okay, so dot plot, stem and leaf, not super appropriate. Dot plot is not going to show the change over time. It's just going to show like how many were in this and this and this and so on. Stem and leaf stem and leaf and dot plots are basically the same thing, just kind of turned sideways. A dot plot looks like this way, whereas a stem and leaf is like this. So those basically being the same thing, not really appropriate. Circle graph though, yes, it would show the fraction or percent of hits each month. So visually you could look at that very quickly and decide that was an appropriate display. And just kind of a side note here, that's the point of all of this, is to decide, like, statistics are huge, as we know from our persuasive essays. And so, like, if you can capture somebody's attention very quickly and they can see what it is that you're trying to show, that's kind of the point of using these appropriate data displays. Okay, so that being said, sometimes they're going to try to be misleading to get you to think things are the way that they want you to believe. For example, the box office revenue from 2005 to 2011. When you are looking at the first one, the first graph here, and I should tell you that these two are the same set of data. So this is misleading because of the break, right? It's showing you that it's beginning at 8, so it's making this look like a big increase when it's really only from 9 to almost 11. And that's in billions. Whereas when you look here, you can see that, yes, it is increasing, but it's not as drastic as this one. So this one is misleading because of the break. And I'm going to say it makes people think the change is more drastic than it is. Okay, moving on, one more example, 2 more on your own. Here we go, example 4, this is laughable actually. If you look at the chart there, a volunteer concludes that the number of cans of food and boxes of food donated were about the same. Is this conclusion accurate? Well, when you look at the little key down here, you notice that each of these cans represents 20, and each of these huge boxed foods also represent 20. So this is not accurate, because it looks like the boxed food is almost equal to the canned food, when really it's just taking up more space because of the picture. This is 20, 40, 60, 80, 120. This is 20, 40, 60, 80, 1, 20, 40, 60, 82, 40. Pretty big difference there. And then the juice, obviously, is pretty comparable to the canned food, but the reason this is so inaccurate is because of the size of the box foods icon. Okay, and last one, last two. Try these two on your own, come back and check. Okay, so here we go with 6 and 7. On both of these, they are misleading, obviously. For the first one, it's actually for 2 reasons. Number 6, there's a break in the graph, which is making it appear to be a greater difference in the beginning. And also, I don't know if you noticed this, but the tickets are getting bigger and wider. So it's just all in all misleading. Same thing with number 7, the bars are becoming wider, which would visually make somebody think that the profits are going to be bigger. So these are all scams that companies or advertisers are using to make people believe things that are not actually true. And that is it for 9.4. So, yeah, hope you guys have a wonderful day, and I will quote unquote chat with you later.